Are you one of those who love to play basketball? Or have you ever observed or experienced to dribble a ball? The moment I throw this ball to the ground, obviously, it bounces back to my hand. That forceful coming together from the ball and in my hand is called collision.
So what is collision? Collision involves two objects coming in contact with each other for a short period of time. It is an interaction between two masses for a short interval wherein the momentum and energy of colliding masses changes. Collisions can be classified into two main categories: elastic collision and inelastic collision.
Elastic collision occurs when two objects involved remain separate after the collision. The best example of an elastic collision would be when a ball at a billiard table hits another ball, or when dribbling a ball.
On the other hand, in the inelastic collision, the objects stick to each other or move in the same direction. The total momentum and energy are conserved, but the kinetic energy is transformed into other forms like heat and sound.
Since the two masses follow the law of conservation of momentum and move in the same direction with the same speed, then we have m1v1 plus m2v2 equals quantity m1 plus m2 times v. Kinetic energy before collision we have. Kinetic energy after collision we have. According to the law of conservation of energy, wherein Q is the change in energy results in production of heat and sound.
A clear example of an inelastic collision is a car crash. Cars are made to crumple up when crashed to another object because our body cannot handle such impact. Another example would be in formation of planets. When an asteroid bunch up together with bigger asteroid, they basically fuse to form a planet or larger body.
Let's try this sample problem. Car A is 100 kg moving at 45 meters per second and car B is a 50 kg moving at 60 meters per second in opposite directions participated in a head-on crash. Let's calculate the final velocity. Since this is an inelastic collision, we will use this formula. m1v1 plus m2v2 equals quantity m1 plus m2 times v. Then, we will get the final velocity, which equals to 50 meters per second. To know the momentum before and after collision, we will use the same formula. As we can see, the momentum before and after collision is the same, which is equal to 7,500 kg meters per second. Therefore, the momentum is conserved.
Generally, the law of conservation of momentum holds true in the collision of two masses, both in the elastic collision and inelastic collision.
But there are some collisions where kinetic energy is not conserved, but transformed to other forms of energy, such as the inelastic collision.
In our everyday lives, we encounter collisions.
Because of curiosity, we were able to determine that collisions are not just traumatic events.
But it could also be small and minimal.